Hello students, in previous session we learnt about the meaning of electric potential and potential difference and their significance in a given electric circuit. Now we know the meaning of electric potential and potential difference. In today's session we'll define them. Before starting with the definitions, first let us try to understand the meaning of electric field, which is a very important term for our discussion. So what is the definition of electric field? Electric field is defined as a region around a charged body with which its influence can be experienced. I repeat the definition. Electric field is defined as a region around a charged body or around a charge with which its influence can be experienced. Now let us consider the diagram shown on the screen. The charge minus Q will have some region of influence around it. In this region, if you were to place another charge like the one shown in the diagram, plus Q charge, the charge plus Q is attracted towards the charge minus Q. The attraction of the charge plus Q is because of the influence of the charge minus Q. Hence, electric field is defined as the region around a charged body or a charge with which its influence can be experienced. The electric field for a given charge will be always limited. If we place another charge within the region of electric field, say of minus Q as in this case, now let us define electric potential. Electric potential at any point in an electric field is the amount of work done in bringing unit positive charge from infinity to that point. Unit positive charge here we mean Q is equals to plus 1 coulomb. So the electric potential is the capability of the charged body to do work. Let us consider when the body is charged, either electrons are supplied to it or they are removed from it. This work is stored in the body in the form of electric potential. Hence, the body can do work by exerting a force of attraction or repulsion on the other charged particles. The capacity of the charged body to do work determines the electric potential on it. The measure of electric potential is the work done to charge a body to 1 coulomb. That is, electric potential is a fraction of work done and charge as shown on the screen. It is V is equals to W by Q. Since the work done is measured in joules and charge in coulomb, the unit of electric potential is joule per coulomb. Joule per coulomb is also known as volt. So, the SI unit of electric potential is joule per coulomb or volt. We know that electric potential is a fraction of work done upon charge. That is, V is equals to W by Q. If the work done W is equals to 1 joule and charge Q is equal to 1 coulomb, then we have electric potential V is equals to 1 volt. Hence, a body is said to have an electric potential of 1 volt if 1 joule of work is done to charge the body to 1 coulomb. And that was all about the definition of electric potential. Now, let us learn the definition of electric potential difference or the potential difference. We defined electric potential with respect to a single point, whereas the potential difference is defined with respect to 2 points. Now let us try to define potential difference. Potential difference between 2 points in electric field is defined as the amount of work done in bringing a unit positive charge from one point to other. I repeat the definition. potential difference between 2 points in electric field is defined as the amount of work done in bringing a unit positive charge from one point to other. So the electric potential difference is the amount of work done to carry a unit positive charge from one point to other in an electric field. In other words, the potential difference is defined as the difference in the electric potential of the two charged bodies. When a body is charged to a different electric potential as compared to the other charged body, the two bodies are said to have a potential difference. The SI unit of potential difference is volt. Potential difference is given by the formula V is equals to W by Q. Now, let us learn to define 1 volt of potential difference. Potential difference between any 2 points is said to be 1 volt if 1 joule of work is done in bringing 1 coulomb of charge from one point to the other. I repeat the definition. Potential difference between 2 points is said to be 1 volt if 1 joule of work is done in bringing 1 coulomb of charge from one point to the other. And the instrument which measures potential difference will be voltmeter. And this was all about electric potential and potential difference. The next topic of our discussion is the property of electric resistance. As the word suggests, resistance is the opposition. Here, electric resistance is opposition to current. We know that current is the flow of charges. By charges, we mean electrons. Hence, the flow of electrons from negative of the cell to the positive would constitute electric current. When these charges move along a conductor or a wire, the atoms or the electrons of the conductor or wire would oppose the flow of electrons. This will oppose the flow of current. Hence, resistance is defined as a property of conductor by virtue of which it opposes the flow of charges. The symbol of resistance is capital R and SI unit of resistance is ohm. The circuit representation of resistance is given by the symbol on the screen. The formula for resistance will be given by Ohm's law. Now, let's begin with the topic of Ohm's law. When we talk about current, it would be in relation with the flow of charges. And these charges flow in a given circuit from a region of higher potential to a region of low potential. Hence, it can be stated that in a given circuit, charges flow and we get electric current. This is possible only if there is a potential difference in the given circuit. And the source of potential difference will be a cell or a battery. Hence, it can be stated that current would more depend on the potential difference. That is, capital I depends on capital V. Only when we have potential difference in a given circuit, charges flow, that is they circulate to constitute electric current. Ohm's law was given by German physicist Georg Simon Ohm in the year 1827. It gives a relationship between current capital I flowing in a metallic wire and potential difference capital V across its terminals. According to this law, the electric current flowing through conductor is directly proportional to potential difference across its ends, providing the physical conditions such as temperature remains unchanged. If capital V is the potential difference applied across the ends of a conductor through which capital I the current flows, then according to Ohm's law, we have V is proportional to I, that is at constant temperature, or V is equals to IR, or it is also given by I is equals to V by R, where capital R is the constant of proportionality called resistance of the conductor at a given temperature. From the above formula, it is clear that current is inversely proportional to resistance. If resistance is doubled, then currents get halved, and if the resistance is halved, then current get doubled.